Okay, and welcome back to the bench. I know you guys like to see my handsome face, but I'm going to have to not be on camera tonight. In a previous video, a while back, I showed this Megohm bridge by General Radio. And at the time, I was like, what do I do with it? Do I strip it for parts? I have absolutely no use for this thing. The Megohm bridge is made to test resistance up into the very extreme high megohms, okay? And they use it for testing insulation resistance, things like that. So I really don't have anything to use it for. But I've had this thing in my house for a couple of years. It was actually, you got a shadow on it. It was actually given to me by someone, and it's been sitting here for a couple of years. And I decided to fire it up. So this will be the first power up of this unit, and I don't know how long. So normally I use my PR57 to fire things up, but I wanted to do something a little different. I don't have a power cord. I've got to use alligator clips going onto it. I'm going to use the dim bulb. I'm also going to use the variac, and I marked where it's 115 volts coming out. That's what the instructions say it's supposed to work on, is 115. So what I'm going to do is I'm going to turn it down, turn the power on. But before I do that, I want to put this camera. If I get shocked, I don't want my camera to be destroyed. Okay, so let me see here. Let's raise this up. Try to get up here. Okay, maybe move over. Yeah, I don't have any fancy stuff. I use my cell phone. I use an old camera stand. Okay, first thing I'm going to do is before I turn the power on, I want to test the fuses. So, cords are tangled up here. Okay, I'm going to put this on diode. You can hear it beep. Okay, so I'm going to go across. It's got two fuses on the input to the transformer. Now, interestingly, this unit came in two flavors. It came in a battery pack that fit into this compartment, or with the AC power supply. This unit puts out, the transformer puts out 500 volts. So that's one of the reasons I want to be extra careful. There's a capacitor can down here, which I'm sure is filled with bad stuff, the old oils and stuff that they use. So I'm going to test. Okay. Okay, so looks like I got a bad fuse. That's not a good sign. All right. Yep, got a bad fuse. So I'm going to pause this a minute. I can pull that fuse out, and I'm going to go through my box of fuses and see if I can find one. So interesting, I don't have a fuse puller. All the stuff around my shop, I don't have a fuse puller. All right, what am I going to use? All right, this is what I'm going to use as a fuse puller. Let's see. Let's see if I can get this in here. Oh boy, it's tight. And beautiful. Look at this. The end is broken off. Okay, time to get the pliers out. That goes into my junk. And get my pliers and pull that out. And these are, looks like it's a slow blow fuse. I'm gonna have to look this up. I do have the specs on my phone. I didn't print it, but again, turn this off. Let me figure out what kind of fuse I'm gonna need, and I'll be right back. Okay, so as you can see, I have a lot of 3AG fuses. I've got slow blows, I've got a lot. This calls for an 800 milliamp slow blow fuse. Okay, I don't have that. But I do have a 1 amp slow blow fuse. So that's what I'm going to use. Let me swing you back around here. We'll get this fuse back in place. It'd be good if I tested the new fuse, huh? Okay. Okay, looking good here, Billy Ray. Looking good. All right. So, these 3 fuses here are off. I'm going to turn the variac on. I've got the dim bulb in. Okay. Let's turn the AC power on. Again, the variac is all the way down. I don't see anything happening here. All right, again, like I said, this is first power up. So let's see what we've got going on here. Put this on AC volts. And let's see if we got some AC volts here. We've got 36 volts. 36 volts. Okay. I'll bring this up. Yeah. There are 2 neon bulbs here. I haven't cleaned anything. This is just the way it is. So the bulb isn't lighting. I don't see anything going on with that. But I do have power coming in because it looks like this neon is on. I don't know. Let's turn all of this stuff on here. Can't hurt it. Okay. We're about halfway up with the voltage. I'm going to take it up a little slow. Yeah, let's bring the meter back. I wish I just had a little bit more room on this bench here. Which you can't see the meter. Let's see what kind of voltage we have across this now. We're up to 56 volts. I'm going slow because there's some capacitors in here. I'm not too concerned about the oil capacitor, but there's some paper caps in here. I want to give them a little bit of a chance. I don't want to just throw full power at them. Okay, so things are looking pretty good here. I say that because the meter has now swung over. Just to let you know, I have no idea how to use this thing. I've never used one. Let me see if I can bring this in a little bit better here. I've never used one, although I've used the Wheatstone bridge. And that's what this has in here, is a bridge circuit. Let's put this, I did read some of the directions. We'll put this on check. And when you put this on check, you're supposed to zero, very sensitive. You're supposed to zero the meter. Okay. Then you put it on operate. Okay. Okay, this is just, let me see, I'm going to, the lighting is kind of putting glare on everything. That's a little bit better. Get you in there so you can see a little bit better. Let me see. Let me grab some high value resistors here. Let's see what I can find. All right, so this looks like, this is supposed to be a, this is supposed to be a 20, see over here it says unknown resistor. So, hope I don't get electrocuted here, because I don't know where that 500 volts goes. Okay. That was a red, black, I believe it's green. It's either a green or a blue, but let's see what we've got. It's definitely up there. So we'd have this zeroed. Let's get in a little bit closer here. Okay. It is zeroed. I'm going to put this on operate. This is on multiply by 10, so that would be 10 times whatever this is. So let's now move this. I can't get both of them in at the same time. But I'm going to move this back and forth until I get that to re-zero. All right, going down. Oop, too far. Let me go back and check this. Okay. Okay, so if I come back and I read this, it would be 20, almost 24 times 10. I'm thinking that's about 24 megohm, because this is in megohms. This readout here is in megohms. And times 10 would be 24 megohms. Okay. And let's swing this back. I'm going to move this down to the 1 times 1. You can see the meter swung all the way back. Now I have to bring this dial all the way up my tripod. Sorry about that. making you nauseous here with moving this thing around. I'm going to move this. Yeah. I'm going to go back, put this here, make sure everything's okay. Well, now it's reading 50 something, so not quite sure what's going on. But when it was on the times 10, it read 24. Okie dokie. So let's take a look at that resistor. That's 20, and that's a blue, so that would be 6 zeros. All right, it'd be 20 megohms. Let's verify that with the fluke. Pull this up. I'm going to take it. I don't want to put it on the fluke here. I will put this up here. I'll swing you guys. No, you can't do that. You can also see that the light bulb is now lighting up a little bit. I'll put this on ohms. Now let's see what it reads. About 23.5 megohms. So this thing was right on. I mean, I don't know the problem when we went up to the different scale, but when we were on the times 10 scale, we were at 24 megohms. So 23.5 megohms is right where it should be. Let's try a different resistor. Let's see what else I got here in megohms. It's not like I keep a whole supply of high megohms, but working with old tube gear, sometimes you need high end. This is a brown, looks like brown, green, and blue, or brown, green. Yeah, let's see. Yeah. Brown, green, and blue. 15.6. Okay. Let's go see what it looks like on the Megohm bridge. Let me put it in here first, and then I'll swing you guys over. All right. Come back over. Again. Neon's only got one neon lit. I'm not quite sure why, but again, I don't know anything about this. I believe one of these was for the bridge and the other is for the detector. I'm not sure what's what here. But if we look back over here, we're on the times 10 again. Let's make sure this is zeroed. It's still on 0. And where do we go here? Yep. Swing around. 15.5 times 10 is 15.5 megohms. Almost identical to what we got on the fluke meter. So this is working. Now I'm going to bring this over here. Now when I electrocute myself, I'll have it on on film here. Okay. What are we up to in voltage? 64 volts. Okay. 64 volts. Not quite sure. Anyway. Okay, 64 volts. Let's bring this up. You can't see that because that light is right on there. You can see the bulb isn't quite as bright as it shows in the camera here. You'll also see now that the other neon is lighting. And what kind of voltage do we have here? $68. 68 volts. All right, like I said, okay. Bulb is, this instrument is supposed to be 30 watts. I have a 100-watt bulb in here, so it's lighting that bulb up. There's something not happy in here. I'll put the fluorescent back on. Okay, there's 5 tubes in this. There's 2 rectifiers. There's a 5U4, a 6X5, a 6J5, and I don't remember what the other one is. I apologize for that, but okay. So it's working. You can see well, you can't see because I don't have the camera on it. As the voltage goes up, I have to re-zero it. And I'm wondering if I go here, times 1. Yeah, maybe before there just wasn't enough voltage because now I'm on times 1. I'm on times 1 over here. I'm at 15. It's under 15. It's under 15 here, but the reading's getting closer, which means the voltage probably has to be running at full voltage in order for this thing to work properly. I am getting a little bit nervous. Okay, sorry about that, but while I was recording, I ran out of storage space on my phone. I had to sit down and do some deleting before I came back. Like I said, this bulb is, it's brighter than I would like it to be. It's a 100-watt bulb. It really shouldn't be that bright, which means I probably have capacitor problems. But again, it is working. So if somebody wanted to rebuild this and get it working at 100%, it probably wouldn't be a problem. That being said, I'm not going to do it. I'm going to shut the power off on this now. A little bit more voltage, maybe. I don't know. I got to shut the power off. I'm going to take this part out. It's getting warm over here. It's all these tubes in here. Okay, and show you what it looks like underneath after I get it done. I'm also going to take out the power supply so we can get a good look at the power supply underneath. Again, I am not going to rebuild this. I've been sitting here curious whether or not this thing would actually work or not. So it does work. The last time it was calibrated was 24 years ago, actually 34 years ago, 1990. 1990, yeah, wow, time flies when you're having fun. 34 years ago. So it seems to be, at least on the times 10 range, to be accurate. But let's see. I'm going to put you guys on pause, take this all apart, lay it out so we can get a better look at it. Okay, so I have it apart. This is a connector that's supposed to come off so that you can swap power supplies going from the AC power supply to the batteries, but I'm going to leave it connected. I don't want to play with it. Over here you have a 6K7, and that's part of the bridge circuit. I just want to show you some interesting things. I mean, this was built with quality. Look at these high quality resistors that are on here, wire wound. Now, we talked about not being accurate on all the ranges. I mean, if you look at these terminals here, some of them are actually gummy. Yeah, gummy. So they would need to be cleaned. You have a wire wound in here, precision. Okay. Relay, a couple switches. Of course, you've got the meter sitting in here. Everything is, if you look, this is cloth on top, wrapped around the wires. Just quality workmanship on this. Okay, and we come over here now. It does have 5 tubes. Okay, it's got a 4A1 ballast, so there's a ballast tube up in here. All right, and it also has a 6X5, a 5U4, 2 rectifiers, a 6K6, and a 6J5 as regulators. If you look at the construction on this, these are all surface mount tube sockets. If I don't sell it, I might scrap it out just so I have for parts. A terminal board, phenolic terminal board that everything's mounted on. That's a good 1/8 of an inch thick. There are more oil-filled capacitors than I thought. There's 2 of them right here. These are 2 1 microfarad 600 volt capacitors. There is another one sitting down in here. I don't know what the value is on that. But the workmanship, and here's what's interesting. If you look at the tubes, they have little tags on the sockets. Each one has a tag telling you what the tube is. That goes there. Yeah, I know, it's a little, okay. Pretty interesting. Everything is done very well on here. So that's going to be it. I'm not doing a restoration on this. I'm sure it's going to need some work. I don't know about these capacitors, the quality of them. If we get around here and we look, you got this transformer here. This is a big, heavy transformer, 500 volt transformer. Resistors, again, I don't know the values. I'd have to look, but if anybody is interested, it would make a nice restoration, even as something, as a novelty if you can't use it. Unfortunately, not my cup of tea. So, hope you guys enjoyed this look at the General Radio 544B Megohm bridge with the power supply, not the battery operation, with the power supply. That's it, guys. Hope you enjoyed it. Subscribe, click like. I keep saying it, but I'd love to see my subscribers pop up a little bit. Trying to do some different things. So with that, take care, guys. Leave some comments too. Comments are always welcome. Again, I don't know a lot about this piece of equipment, but it does work. And who knows? It probably will go on eBay as a local pickup because this thing weighs a ton. I'm not shipping it. I know they're out there. People are asking a ton of money for them. I'm looking at $50 local pickup. So again, that's going to be after the first of the year. It's currently the 9th, 8th, the 8th of December. So after Christmas, it'll go up on eBay. Take care, guys.